Yeah. Welcome back. I've been really to all the breakout rooms. I'm very pleased by what you guys all did. Very, very minor little mistakes, nothing really major. So I'm happy to see this. I'm gonna quickly write this code with you here, taking any comments. There was only one major issue with a couple of you, is that this table does not include all the cases. So these are some specific cases. For example, when x is greater than 0 and y greater than 0, this does not belong to this table. Then in that case, all what you need is that theta is 10 minus 1 over x. Okay, so let's develop this script very, very quickly. It's not difficult at all. So let's save it. I'm gonna call it as, maybe Cartesian to polar, or is it, yeah, Cartesian to polar. So x equal, of course, it's recommended to do CLC at the beginning and clear all. X equal input, and let's put here enter value of x. And similarly, you can say y equal input and enter the value of y. And then you can calculate r right away. So r equals the square root of x squared plus y squared. And let's put a semicolon. And then comes theta. Theta, if you go to the document, it's 10 minus 1 y over x. So 10 minus 1 is a tan. So basically, it's a tan y over x. The only thing is, some of you actually put a d here. If it's d, it's gonna make it a degree right away. I can actually do this. Maybe I can call this theta d, which is the theta degree, right? And I can call another one theta rad. So maybe I can call it explicitly theta rad, and this is theta dig. So theta degree is gonna be tan d y over x, while theta rad is gonna be a tan y over x right away. So that's one for the degree and one for the radian. Then the truth table, if you can call it this way, you can call it a truth table. In fact, as we said, it doesn't include all the cases. These are the annoying cases, if I can call them this way. But otherwise, or all the remaining possibilities, the theta is simply the tan minus 1 over x. So let's do this quickly here. If x is greater than 0 and y is also, sorry, if x is less than 0 and y is greater than 0. Some of you 2 ampersands, like 2 ands, this is fine. So typically 2 ands for scalars, 1 and for arrays, but still MATLAB deal with these as arrays. So, so both of them are gonna work. Maybe I can put 2 ands here because these are scalars. Then what's gonna happen is that theta dig is gonna be theta dig plus 180, right? And similarly, I have to be consistent here in the naming. Theta rad is gonna be theta rad plus pi. So that's the first block here. And then else f. The second possibility is that x is less than 0 and y is less than 0 as well. Then I can do these two, copy, paste. So this is gonna be with a minus, and this is gonna be with a minus. Similarly, else. If some of you separated, like wrote f else or some other different syntax, just stack to the syntax here. It's else f one word. So if x is less than 0 and y equals 0, is the third possibility, it's gonna be basically the degree is gonna be 180, and the radian is gonna be pi. And another one, else f. So the fourth possibility, x equals 0, and y is greater than 0. That's the fourth possibility. What's the answer is going to be pi over 2, right? So the answer is going to be 90 here, and here it's going to be pi over 2. I'm just copying from the truth table, no more than that, or from this table here. Then finally, or actually the case before, so 1, 2, 3, 4, the case number 5, if x is 0 and y is less than 0, then what are the possibilities? Minus pi over 2, so it's going to be minus 90, and this one is going to be minus pi over 2. I think the last possibility in the table is f x is 0, and you have to leave spaces between the 0 and the and. Otherwise, it might create an error. And visually, it's easier for your eyes to track errors when you leave a space between the and. And the last one, when both are 0 here, basically, we have the angles equal 0. This guy is going to be 0, and this guy is going to be also 0. Some of you made an end here and we are done. Unfortunately, this is not inclusive of all the possibilities. There are possibilities that are not on the table. In particular, there is x greater than 0 and y equal greater and y greater than 0. So basically, if it is none of these cases, if it is really none of these cases, then basically your calculation on the top here, that theta degree is a tan dy over x and theta rad is a tan y over x, is correct. And you do not need to modify it. Basically, you don't need to do anything, right? So only the F statements if x is not greater than 0 and y not greater than 0, okay? So after this, I think that's it. We need to display the results for the user. So you can display the value of R as, and you can disp R, and finally disp the angle in radians is, and then you disp variable. That's also one mistake that some of you wrote the display theta. So here it's theta rad. Some of you actually didn't put this between two quotation marks. Sorry, they put it in quotation marks, which is gonna display a text, but we need the actual variable, okay? And finally, we can copy this. The angle in degrees is theta dig. Now it's complete, so I can save it. Let's try to run. Let's run here. Let's test one case. One of your colleagues actually suggested it in one of the breakout rooms. So 3x is 3, and y is 4. Sorry, y is 4. So that actually gives us the following answer. The value of the radius is 5, the angle in radians is 0.92, and the angle in degrees is 53 degrees, right? Let's do a test case from the table. So the first one, x is 1 and y is 0. Let's run this case. X is 1, y is 0. And let's see. R is 1, the radius is 1, the angle in degrees is 0, and the angle in radians is also 0. So, and that's what you would expect, because if x equals 1, and I'm not moving along the y-axis, really the angle is 0. Let's do, for example, 1 and 1, the case when x is 1 and y and 1. Imagine it, x is 1, y and 1. This is going to be 45 degrees. So let's run this one more time. This is 1, and this is 1. So the radius is 1.4, and the angle in degrees 45, and that's how it looks like in radians is pi over 4. Okay. All right, guys. So let's stop here. We took a little bit extra time, but we also started late. We had some technical issue at the beginning, so we started a little bit late. But I hope you learned something and enjoyed today's session. We usually are gonna go with this format where basically we have one exercise, we introduce some syntax, we do exercise together, and then I leave you one more exercise in the breakout rooms, we do it together, and so on, okay? The Word document in the Google Drive, it actually contains extra exercises for you if you wish to practice more. Feel free to ask next time. If you have any questions, we can stay after the session a little bit, discuss any of these questions. Again, looking forward to your feedback. If you have any, please send to the ASME students, the organizers of this event. If you have some feedback or suggestion, we are welcoming this. Thank you so much. See you next week. Bye.
Professor, I have a question from the
Yes.
shadowing.
Yes.